Howdy, I'm Kate Davis and welcome to our data fusion tutorial. I would like to introduce Zayu Mao and Abhishek Sahu, who will walk you guys through this hands-on activity.
The primary motivation of performing this research is it is very hard to get data sources which are cyber physical. We either get data set which are pure cyber, like you get network logs, or you get pure physical system data from some kind of simulators. You can simulate in Power World, MATLAB, but we don't have data set which are the combination of both. So it is highly essential to have data fusion from these diverse sources so that we can make proper inference and can protect our grid from intrusions. So what are the data sources that we are exactly collecting in our case? We collect raw packet captures using Wireshark tool at the DNP3 master. We collect the Wireshark the packet captures at the outstation, and also we collect packet captures at the router. We collect the snot logs from the snot running in the substation router, and we make use of a PyShark tool. PyShark is a Wireshark Python plugin to collect additional feature which we may find it difficult to collect from the raw packets. And there is a packet bit tool. It's kind of an plugin in the Elasticsearch where you can capture network traffic from the network interfaces. Either it may be virtual interfaces, network bridges, so we can collect real-time traffic. And also there is a Kibana platform where we can visualize this while we are capturing those traffic.
Thank you, Abhishek, for introducing the problem and the data sources. Now, Zayu Mao will walk you guys through the hands-on steps to take a look at the fusion of this data and how to analyze it and what you can observe from it.
Okay, so let's assume you have the Google Colab activated and you open this one. So the first one we will do is to run the first cell, which will obtain the dependencies that are required for this hands-on from GitHub. So you could either click the button here, or you could just press Shift and Enter, and then run anyway. So after the clone is ready, you should observe the folder in the files here, and then you will change the directory to the folder. Okay, and now you need to install the dependencies required for this experiment. For this experiment, we are using PyShark and also intrusion detection system tools. Okay, so once it's done, we will initialize an object. The object is a data fusion object, which will be used as a container to fuse the cyber and also the physical data. We will run this cell as well. And then the first data we will be merged, which will be the JSON file from the Wireshark, which basically contains the packet data, right? Contains the packet data. We will run this one. And then once the JSON file is loaded, we could then extract the cyber data from the JSON files that generated by Wireshark. Here, as the table shows, you could see this is cyber data we extracted from the Wireshark file. It has like packets length, packets protocol, and also a bunch of information indicating its cyber stack information. And now we will merge the cyber and physical from multiple locations. In data fusion, there can be multiple sensors that can be placed in different locations. For example, in our case, we have considered PCAPs from different locations, such as the VM where the outstation is running, and also from the routers in the core, as well as from the DNP3 master. So for this cell, we will load the PCAP file. The PCAP file are from the routers and VM. And once it's done, we will extract the PCAP file to pass the data. So in the PCAP file, we have TCP retransmission and also the round trip time and with timestamp. So now we have packet data. We also have the flow data. Oh no, this is not the flow data. We have the packet data. We also have the TCP stack data. Now we will merge the two types of data together. So you could see here the retransmission and also the round trip time has been merged. And then we will extract the logs from intrusion detection system, SNOT. Once we extract some fields from SNOT, we merge the SNOT fields into the cyber table. So here shows the information we parsed from SNOT logs. And then we could then merge the SNOT data into the cyber data that we already created. And then we will also retrieve the packet bit data from the Elasticsearch and then merge it to the cyber table. Yeah, for this one, for Elasticsearch, it will provide the network flow. It will provide the network flow data, which is quite useful to detect some 0-day intrusion. For this one, we will run the second cell. Oh, sorry, no, we will run the optional step because so the first part is actually connected to a Elasticsearch server, but yeah, how to merge these two, I don't know. Yeah, but this is impossible for all the cloud container. So So we will run this optional step, which we already pre-saved all the packet bit data into a Pico file so that you could just load the Pico file here and then merge the packet bit data, which is the network flow data. Yeah, it will take about 1 minute to finish. So after this step, we will have the cyber data that contains not only packet data, but also flow data, but also intrusion detection system data. For the cyber data, yes. And then after this step, we will extract physical data from DNP3 link layer information. It extract each application payload based on the function code. In this demo, extraction has been done for function code, read, direct operate, and also enable spontaneous message, disable spontaneous message, DNP3 response. For this case, we collect the discrete states and discrete control from the outstation, but we also implement the function to retrieve the analog data. So so after this step finish, we will extract the physical data. So the physical data is in the DNP3 link layer. And then now we have the cyber data, and physical data ready, we could merge them together by running this fusion.merge. So you could take a look at this table, which contains both cyber and physical information. And if you run this cell, it also shows how many types, how many features we have in this fused cyber physical data table. You probably noticed that there are a bunch of data that is missing in the merged table, which we need to impute it to replace this missing data. For this one, we will running this cell. After this one is finished, we could save the data to a CSV file, save the merged data to the CSV file. And then it's an analysis and visualization process. To visualize the data, what we could observe that some of the features are string. And to visualize this string, it's actually quite hard. What we could do here is to do the categorical embedding, which basically embed this string into some meaningful numerical values. By running this cell, we could say like the frame protocol and also the destination of IP and also the destination packet and source of packet has been transformed into numerical values. We could run this one to save to CSV as well. And then we could visualize the merged table by running this cell. The data will be plotted based on time. So from the plot, you could observe some interesting pattern. For example, you may notice some jitters here and here, which indicates some anomaly network traffic at the moment. And you could also find here the network traffic here is corresponding, some of the event here is corresponding to the snort event as well. And then what we could do the dimension reduction to remove some of the features that is not important. We could using PCA principal component analysis to do that. And then we could also visualize the result after the dimension reduction to see whether it makes sense. From here, you could see the features has been projected to a new 2D space, and the snort alert shows whether the data at that time has has evidence, has like a indication that it is compromised, which you could see from the plot that those not alert, those data points are quite close to each other, which showed they have a strong correlation in its own class. We could also visualize using a more advanced visualization technique, which is called T-distributed stochastic neighbor embedding. So TSNE is also a tool to visualize high-dimensional data. You could run this cell to see the results. You could also observe that the data from the compromised movement is quite close to each other, which showed a strong correlation, internal correlation. And we could also use interactive plot to analyze the results in detail. So this plot is interactive. Yeah, so basically that's all for the data fusion hands-on.